What if this circuit that I'm trying to analyze using mesh current contains a current source? How would that affect my mesh currents? Well, let me show you with an example. In here, I have a circuit, and this particular circuit has two sources. One is a voltage source and one is a current source. And you can readily see that we have two meshes in here. So I'll just name them right away, or I'll identify the mesh current. So the first one is in here, that's IA, and I'm going to call this one here IB. Okay, or maybe lowercase b in here. Okay, so how would I do that? Well, if we go through our normal route, we'll say, well, we're going to write our mesh equations. So the first mesh using mesh IA, let me call it mesh A, for example. We can simply say it's -10 for the -10 volts because the current is going that way. And then plus 4, well, the 4 is only affected by IA, plus 6, and because it's from the perspective of the first mesh, it will be I1, and IB is actually opposite, or IA, sorry, minus IB, okay, and that should be equal to 0. And that's basically the first equation for the first mesh in here, okay? And you can clear this up a little bit, and you will see that it will be 4 plus 6, which is just simply 10, 10 IA, okay? Let me just do that here, 10 IA, minus 6 IB, and that should be equal to 10. Okay, and that's pretty much the first equation that we have. All right, so let's go and write the mesh B. Okay, so here's mesh B. Okay, what about mesh B in here? Well, let's take a look. We can, of course, we can go ahead and start writing 6 times IB minus IA, 3 times IB, but then remember we're writing KVL, and I don't know what the voltage across that particular source in here. And as it turns out to be, for this particular case, I do not need to know that voltage. Actually, I don't need to write an equation at all, because if you think about it, the branch current that is flowing through that is 5 amps, and the 3 is pretty much 5 amps. I know what the branch current is because I know what this current source is providing. So as it turns out that this particular current will force this mesh current to be equivalent. Well, because I assumed they're in the same, they're in the opposite direction. IB was assumed to be that way, and the current source is going that way. So that simply say the IB is -5 amps. It's just because I assumed it to be this way. If I assumed it in the opposite direction, it would have been just 5 amps. Okay, so what do I do now? Well, I'll take that -5 and I just substitute it in here. Okay, all right. So we substitute that in here, and we'll say that 10 IA minus 6 times -5 equals 10. Okay, so that tells me that, and I can basically compute what IA is. I know how much is my IB. I can figure out anything I want. For example, if you wanted I naught, well, I naught based on this particular circuit, it is in the same direction as IA, opposite direction to IB, so it is simply IA minus IB, okay, which is -2 minus -5, okay, which is 5 minus 2, which is 3 amps, okay, and you can compute that voltage and so forth. You can compute the power, you can compute everything you want about this circuit. Okay, so now this is the simple case when the current is actually, the current source is just also the branch current and is also the mesh current. But let's take a look at the little bit more interesting case. In this particular case in here, and we'll solve it with what we call a super mesh, but in this particular case, what we have also two meshes, okay? So the first mesh will be here, for example, this will be IA, for example. This will be, well, let me call it 1 and 2 so that you don't confuse it with the previous case. Okay, so let's call this I1, and this one here is I2. Well, as it turns out, in this particular case, 6 is neither equal to I1 directly or I2. As it turns out that I2 and the I1 both gets somehow constrained by that 6 amps. So let me write the mesh equations, or two mesh equations in here, since we have two meshes. So the first mesh, okay, so here's mesh, I will call it I1. Okay, so for the first mesh, I'll say -24 plus 6I1. All right, what do I do with that current? Remember, we're writing KVL. So we wrote the voltage in here, we wrote voltage in here. I don't know the voltage across a current source, so I'll have to assume it somehow. So what I'll do is I'll assume that this here, plus minus, and I'm going to call it V. Okay, so I'm going to say, well, that will be plus V, and of course, it's equal to 0. All right, so let's do this here, the same exact thing with mesh I2, okay? So for mesh I2, I'll start with the 10, for example, I2 plus 2 I2. Well, what do I do with that here? Well, it's the same voltage that we have, okay? We assume that it's in this direction, so I'll say -V. And okay, I'm going to do that in the same color. So that will be -V, and of course that here is equal to 0. All right, so we have, remember, it's like mesh currents, our goal is to end up with the mesh current values. That's why we're doing mesh analysis. But if I take a look at these two equations, I have one in here and I have one in here, well, I1 and I2, and also I have V. But if you have paid attention that this is plus V and this is negative V. So if I add this equation to this equation in here, I'll end up with the following. I'll end up with negative 24 plus 6I1 plus 10I2 plus 2I2 equals 0. All right, and as it turns out to be that this is actually one of the equations that I'm interested in, I will need, of course, a second equation. So where do I get the second equation from? Well, we can get it from this current source in here. So what this current source tells me is, this current source is a combination of I1 and I2. Okay, so it basically forces I1 and I2 to have some sort of an equation, or like it constrained them. So what is that constraint equation? So let me just show you. The constraint equation, okay, and it's the constraint of the 6 amps in here. It tells me that pretty much 6 is equal to I2 minus I1. So let me pay attention here. 6 is going that way, so I2 is going in the same direction. That's why I2 is in the positive, and of course I1 is in the negative, so that's negative I1. So actually, this is the second equation I'm looking for. So it's a constraint equation that comes from this particular source. So in this particular case, the current source is not exactly the mesh current. Pretty much like in the previous case, we had the current source was exactly the mesh current. No other mesh currents is affecting it. This case, it's actually constraining these two mesh currents to be this way. So what we need to do is we need to just basically solve these two equations, and you'll figure out I1 and I2. And I went ahead and I did that, and you will see that I1 will be simply negative 3.2 amps and I2 will be 2.8 amps. All right, so the reason why I'm covering in here is I want to talk about what we call a super mesh. So as it turns out that you do not have to write first mesh and a second mesh and assume that plus V. There's a little bit of a faster way to get to this particular equation right away, and that's what we call a super mesh. So let me just clean the graphs in here, and we'll end up with the same equation. Okay, so I shifted things a little bit, and what I'm going to do is I'm going to write what we call a super mesh. Okay, so what is a super mesh? Well, as it turns out that if you have a current source like this one here, that is on the boundary between two different meshes. So we have a mesh in here and we have another mesh in here. And as it turns out that if the boundary between these two meshes contains a current source, what we can do is we can use a super mesh. Again, let me just repeat. What you need is two meshes, and the boundary of these two meshes, there's a current source. What you can do is we can do a super mesh, and the super mesh is written in such a way it's the following. So we'll assume that the super mesh is actually something that combines both meshes together, and what we will do is we will assume that that particular voltage source in here, okay, or the current source, sorry, that particular current source in here does not exist. That's what we're going to do. It does exist in reality, but we're going to assume that it does not exist. So you mentally remove it. I have removed it here in the graph so that you can follow me, but you mentally remove it as if it does not exist. So this branch does not exist, and you write this. You still keep the two mesh currents. There's still two mesh currents in here, and you still keep them. And when you write the equation, you assume it that way. It just, you assume that that particular current source does not exist. Okay, so we do that in here. Okay, so let me just write this super mesh equation. Okay, so this is what we call a super mesh equation because it contains two meshes. Sometimes it might contain more meshes as well, but now let's start with the two meshes. So we'll start like usual. This is the I1, so we'll go to the negative 24 in here. Okay, what happens with the I1 when it goes to the 6? Well, the 6 is only affected by I1, so I will just say plus 6I1, and then you go ahead and again, you ignore this one in here. We just ignored it. You just continue, and what you do see is the 10. Now, the 10 is affected by the second current, the second mesh current. Again, keep them two separate mesh currents. You need them, and when you write the equations, you write them as if like they're two separate mesh currents. So in here, we know that the 10 is only affected by I2, so that's what I wrote. And of course, the 2 ohms in here, you will see that it's only affected by I2, so you do the same thing. So it's plus 2I2. I believe I've finished all the other elements, so all you have to do is just basically say equal 0, and I'll highlight this here, okay, and I will just drag it just to show you what we've done. So we have written this equation before when we did that in here, look. So this equation is the same as the equation in here. This is the equation we wrote by writing the first mesh and the second mesh, and then we added them together, and by adding them we basically got rid of these plus V minus V. But the super mesh was able basically to give me that equation directly without me having to go and writing two separate equations. And after you write the super mesh equation, you will need to use the constraint. So the constraint is always there because it's basically a current source that is constraining to mesh currents to be somehow. So this is how you generate the second equation. You generate like as many equations as you need, you solve them, and you figure out the mesh currents. And of course, if you know all the mesh currents that you need, you just basically go back and tell me what the 6 is, what the 10. Frankly speaking, you'll be able to figure out anything you want, even voltages. Like for example, if you want the voltage across this particular current source in here, you should be able to do that by maybe writing, well, you will know what the voltage in here, you will know what the voltage in here, and you write KVL, and you figure out what that plus V is equal to.